This video is going to be the first in a series about the Math 031 course pack. If you'd like to follow along, you may want to purchase the course pack at the JCC bookstore or follow along on your own paper. As you can see from the table of contents here, we're going to be talking about Chapter 1 first, and we're going to talk about sections 1.1, 1.2, 1.4, and 1.8. Now, as you may have noticed, your My Math Lab homework does include homework for sections 1.3, 1.5, and so on, sections that are not covered in the course pack. But I'd like you to go ahead and do those sections anyway. You're going to use the textbook as your primary resource there and use the videos that are embedded inside the textbook. So on to the first chapter. Chapter 1 is titled Variables, Real Numbers, Mathematical Models, and we're on the first section introducing algebra with variables and mathematical models. Okay, so our first objective here is to evaluate an algebraic expression, and our definition right here is a variable is a symbol that represents an unknown number. I'm trying to write fast, my handwriting's not that good. An unknown number. You can figure out what that says, I hope. An algebraic is an expression is a combination of variables, numbers, and operations such as addition, subtraction, multiplication. I'm not using an X for that, right? Just a dot. Or you could use an asterisk if you wanted for multiplication. Division. That I need to erase that connected on accident. Sometimes it does that. There we go. One of the problems with this software is it's not perfect. So my asterisk, my division, and I can also have parentheses. Okay. Alright, so some of the examples, I could say something like 2x minus 4. This is something that is an expression that has a multiplication. When you see 2x, there's a multiplication implied in between them, though there's no symbol written, then the subtraction. Okay. Moving on, we can replace a variable that appears in an algebraic expression by a number. So this process is called evaluating. Or you can say evaluating the expression, just a longer version of the same thing. Okay, my handwriting looks awful today. In the first example right here, we want to evaluate this expression for x equals 10. So, like the definition said above, to evaluate means to replace the variable with the number. So to evaluate this one, I'm going to write 2, and I'm going to replace that x with a 10. So 2 times 10 plus 6. And we're just going to use order of operations to simplify and evaluate that. So add up inside the parentheses first. So that's 2 times 16. And then finish the multiplication for the final answer of 32. Okay, that's, again, the definition of evaluating and just trying to explain what it's asking us to do here. The next example, another evaluate. This one has more than one variable, and I'm going to plug in x equals 3 and y equals 8 everywhere I see an x or a y in that expression. So it's going to become 6 times 3. Notice I need to use some kind of representation for that multiplication. When I see 6 and x, it's implied multiplication. When I write it down, I'm going to use those parentheses. So 6 times 3 minus 8, that was my y, over 2 times y again, so 8 again, minus x, which is 3, minus 8. So let's simplify this. 6 times 3 is 18, minus 8 on top. 2 times 8 is 16, minus 3, minus 8. So far so good. The top, 18 minus 8 is 10. And on the bottom, 16 minus 3 is 13, minus 8 is 5. And then I finish my division. 10 divided by 5 is 2. So the simplified expression turned into a 2 once I evaluated it for x equals 3 and y equals 8. All right. The next objective is to translate English phrases into algebraic expressions. So we need a couple of words that are commonly used for addition and a couple of symbols. The symbols for addition and subtraction, there's only one of each, but as you've already seen, multiplication has several symbols. So addition, some of the words that might come up might be plus, addition, add, etc. Some of the other ones that sound a little bit less like addition are more than or increased. Those are also going to imply addition without actually saying addition or add. More than or increase or increased by. Subtraction, we've got minus, less than, and decreased or decreased by, or just less. There's a variety of words you could use for subtraction. For multiplication, you usually use the dot symbol. You can use an asterisk, don't just use a regular X, and you can use parentheses. Multiplication words might be multiply. Multiplying by 2, I could say twice, or 3 times, I could say thrice. If I'm using fractions, I could say of, 2/3 of 4. That would be a multiplication with that word of. Put parentheses right there and say that's usually just for fractions or percentages, actually. Okay. Other multiplication words, we could use product. And we'll see if any other ones come up. Those are the ones that came to me off the top of my head. For division, we can use the division symbol, or we could use like a slash to get two things divided by each other, or a fraction bar, two things divided by each other with a straight line in between them, like the previous example. That slash isn't supposed to be so big, but it just turned out that way. Okay, words for division. We can have divide, we can have division. Another common one is quotient. And another really common one is per. You hear that one for division all the time. You're talking about miles per hour. That's a ratio, a division of the miles divided by the hours it takes. So miles per is a division word. Okay. Now that we've got a couple of those division words, let's go ahead and translate some of these, or a couple of those operation words I meant to say. Let's translate a couple of these English phrases into algebraic expressions. The product of 6 and a number. Remember that product was multiplication, so that's 6 times x. I don't have to write a symbol. If I wrote the 6 times x like this, it's okay, but I don't have to write a symbol between a number and a letter to know that they are multiplied. So 6x is the same thing as 6 times x, the product of 6 and a number. Again, my directions right here said I was going to use x for the unknown number. A number added to 4, so I could say x plus 4. Or I could say 4 plus x, because the order that I write things in when I'm doing addition doesn't matter. You can add 2 and 3 and add 3 and 2, you'll get the same thing. 3 times a number increased by 5. Okay, 3 times a number. Increase is add by 5. 3 times, that's my multiplication of 3 of my number. I'm going to take that and increase it by 5. So that sounds good. Okay, those are pretty straightforward. Now we're going to get to the subtraction one. Subtraction is always a little bit trickier because unlike addition, the order does matter. So I'm going to have one order that works and one that doesn't. Okay, twice a number. I know that twice a number is 2x and it's subtracted from 12. Okay, twice a number is subtracted from 12. The way the English language works is it needs to be taken away from that 12, which means I need to have that 12 first and then take away the 2x. It is not okay to have it in the reverse order. If I had it in the reverse order, that's wrong. I can't say it's 2x minus 12. That means something different because subtraction, the order does matter. Okay, so the English language, this is actually the word from right here. In the English language is an indication that I need to be subtracted away from that 12. That 12 has to come first. Alright. On our last example here, we have the quotient of 15 in a number. And again, that word quotient, you don't hear it every day, but it's a division word. Quotient of 15 in a number is 15 divided by x. Most common way to write it would be to write it up and down like that, like a fraction, the quotient of 15 in a number. Alright. These are a couple more things with that subtraction because the order in subtraction is really tricky. All of these examples deal with the number 7 and a variable, so I'm going to use x for the number part. A number decreased by 7. I'm going to take my number x and decrease it by 7, take 7 away from it. A number subtracted from 7. There's that from again. So I've got 7 minus x. Okay. 7 less than a number. Which one of those do you think that is? 7 less than a number. 7 less than a number should be x minus 7 as well. 7 less a number, though, just that word than did that to us. Now it's 7 minus x. Okay, so these two words, than and from, in the English language are going to switch the order of the sentence. So it says a number first, but it's subtracted away from the 7, puts the number last. It says 7 first, but it's 7 less than that number. That number has to come first. Something to pay attention to with subtraction. It's not the math that's complicated here, it's the way the English language works. Okay. Alright, next definition. An equation is a statement that two algebraic expressions are equal. And an equation will always contain the equal symbol. So in the last example, when we had an expression, the expression was something like 2x minus 4. There's no equal sign in that. If I want it to be an equation, I would set it equal to some other expression. So maybe 3x plus 1. Now we've got an equation. The equation must have the equal symbol. Next objective, we want to determine whether a number is a solution to an equation. A number is a solution if the equation becomes true when you plug that variable in. So in the next example, I want to determine if 3 is a solution, so I'm going to plug 3 in for the variable and just see whether or not it's true. So this is 2 times, we'll do 3 for y, so 3 plus 3. Is that equal to 5 times 3 minus 3? So 2 times 3 plus 3. 3 plus 3 is 6. I'm still not sure yet if that's equal to 5 times 3 is 15 minus 3. 2 times 6 is 12. Is that equal to 15 minus 3 is also 12? So this is a yes. Okay, this is a yes or no question. Is it a solution or not? So the question is really, is it true or not? Okay, let me see if I can write a little bit smaller here on this next one. Is 3, again, a solution to this other equation? So let's try 2 times 4 minus 3. Is that equal to 3 times 3 minus 4? Okay, so we've got 2 minus 4 times 3 is 12. I want to know, is that equal to 3 times negative 1? 3 minus 4 is negative 1. So right here I've got negative 10. 2 minus 12 is negative 10. Equals 3 times negative 1 is negative 3. Those are not equal, so the answer is no. 3 is not the solution to that equation. Usually we're going to use something like this to check whether or not we've solved an equation correctly. We'll plug it back in to see whether or not it really is a solution. Alright, so let's go back and look at some words for translating equality. Equality is the equal symbol, so equals would be one of them. Okay, there are other words that we often use for equals. Some words like is are very common to see for equals. Sometimes you also see other words like yields. Yields looks funny there. Okay. And really any verb. Gives, yields. A verb word is going to be the equals word. This becomes this or something like that. Okay. And let's translate a couple of things right here. The quotient of a number and 6 is 5. Quotient, that's division, of a number and 6 is equals 5. Really, I want to find that is and split my equation into the left side and the right side. 7 decreased by a number yields 1. 7 decreased by twice a number. So 7 decreased by twice a number